Yeah, we'll work out. Yeah. Certainly. I'm just trying to make sure I get all of the
can go ahead and use the same trigonometry that we have. Yes? And we could use the cosine rule with that angle 30 and it would work. Okay? So it could work. So let's do this last one. So PQ would be equal to the square root of 8 squared minus 4 squared. Yes? Agree? So 8 eighths are what? 64 minus 16. So PQ is the square root of what?
48.
48.
And what's the root of 48?
6.93.
6.93. 6. Yeah, if you round it up. Yeah, it'll be 3.
Okay, 6.93 centimeters. I think, yes, because we are using centimeters, we're going to work with that. All right. Thank you, guys. Dr. Barker. So again, thank you for those who have joined in for the math clinic. Next week, we continue the same process. We start with the math clinic, then we go into the conceptual learning, and then we will practice the things that we have learned during today's lesson. Yes, for the YouTube link, I will send it through. Okay?
Hello?
Yes, your turn, Dr. Walker.
Okay, good. All right, so good evening. So, how are you, sir?
Good evening.
I'm good, Dr. Walker.
I think we didn't send the reminder. I saw a number of emails asking if lesson is on, so.
Oh, thank you.
Yeah.
Thank you. I noticed that you chipped in for me there. I totally had forgotten.
Yeah.
So, Dr. Barker, today we are looking at vectors.
Yes. It should be fun.
It should be. So what's the importance of vectors for us? Is there an importance in learning vectors?
Of course there is. I think if we think about vectors in terms of the application of vectors into real life, it's maybe one of the most practical part of maths. Because remember, pretty much anything that does navigation, like airplanes, ships, they cannot get to where they want to go without using vectors. Because unlike us on land, we have roads, but they are just in the open sea. So if they can't use angles and directions to get from one place to another, serious problem. So anybody who is interested in stuff like piloting or navigation, working on ships, anything like that kind of stuff, trust me, the application of vectors is amazing there. So I'll certainly kind of explain the piece that has to do with people passing their exams and the topics that will come. But when maybe examples you may have a little bit more flavor to them. I was running a little bit late to this, so I might not have found some of the best examples, but hopefully we can get some good stuff done. So yeah.
Over to you.
Over to me. So let me just get a few things organized here. So I need to get the correct screens ready. So I'll get this one away from the other space. And then, but I hope everyone's all right. Hopefully I don't scare anyone with vectors today, because it's not a, so let me get that right. Hold on. And then I need to share my screen here, right? Just need to get, I'm totally Ooh. That's it. And then inside of the Google Classroom, which, okay, here we are. So I'm going to share my screen. Just let me know if you're seeing it when it comes up. Is it yet? Tell me. I need to know. Okay, fantastic. So let's see how far I get. Good evening again. Today we see it was matrices last week. So this week we are doing vectors. What does this say? Does it say matrices? No, it says vectors. Okay, great. So we're doing vectors this week. So, or somebody's asking, yes, sorry, we made a few changes because we're trying to figure out which topics will certainly be there. And so we're trying to pick the topics that we think students have the greatest challenge with. So as we get closer, just like how Mr. William just mentioned, so Fullerton just mentioned that people are asking about completing the square, and some people are asking about sign rule and so on. We will cover all of those, but we are trying to focus on the things that we know are certainly going to be there first, and then we'll have some little maybe breakout rooms that people may go into and we work on specific topics. So no need to worry. And as we get through today, we will always keep that YouTube link open for students who are having problems, maybe popping in and out. At least I know that the lesson is always there. Following on from that as well, because we're beaming it onto YouTube, streaming it onto YouTube, the lesson is also always there as well. So you can always go back to that lesson. So if someone misses today's lesson, just say to them, listen, you can go on YouTube. The difference with the YouTube experience is that when you're on YouTube, you're not in the classroom. So it's not as easy for me to communicate with you. But if you're in the classroom like you are now, then it's better for you because you can ask your question. So whichever way that works for you, we really don't mind because there's always students wanting to come in. So you choose what works for you and you can be part of it. So let's get going. So today's lesson is on vectors, and vectors is one of those topics that sometimes students have good relationships with, and some that they find it very, very difficult. In some cases, some students, it's not even taught because maybe the teacher doesn't cover it or time isn't there in the curriculum for it. So let's get going. There are a number of things that are related to vectors. We need to know the different types of vectors, perform operations, on add, subtract, multiply on vectors and on position vectors. When I find the magnitude of a vector, I'm going to do some calculations on vectors. So I'll try to make it sequential so that you can follow through and understand what's going on. So the first thing is that what is a vector? In a math exam, you're never necessarily required to define a vector, but it's good to have an understanding because it's something that you'll see in science. So for example, in science, they'll talk about vector quantities and scalar quantities. So they'll talk about, a vector quantity is something that has magnitude and direction, while a vector just has magnitude. And the difference between the two, as you do more science, will become more apparent. But for math, it's just having a basic definition that there are two important pieces on a vector, the direction it is traveling and how big it is. That's what magnitude means. So it's a special type of quantity compared to you say finding the length of something, which is 5 centimeters, and you don't know which direction to go. Now, at the beginning of this, we had a quick chat about the value of vectors. So if you're a ship, you may, if you're on a ship and you're navigating, then maybe we'll say they're going 550 kilometers, 50 kilometers in a particular direction, and then they'll say how, 50 kilometers in a specific direction. Because if you're in the open sea, 50 kilometers can be in any direction. But if they give a specific direction, that will now be seen as a vector. So these are very important things for airplanes and so on to use when they are out there. It's the way that they communicate. That's how they describe direction. They'll not just go 500 kilometers. They'll say 500 kilometers in that direction. And that makes it a vector quantity. So when we talk about a vector, we're talking about magnitude, which means how big the vector is, or the distance, or the size of the vector, and the direction. Now, last week we spent some time doing matrices, and you'll see the connection between vectors and matrices today. So if you were in the matrices lesson, you'll find a lot of what I do at the beginning fairly straightforward. So it's good to focus on the conceptual piece of this, like how vectors work. So a vector, for example, is a line, as we see here, an arrow in that sense, where the arrow indicates the direction that it is going. and the magnitude of it. But we also try to describe the direction in a little bit more. Because if I wanted to describe this arrow direction, I wouldn't be able to tell you that right away. It doesn't make sense if I just say it's going up or a little bit up, but not a little bit. You know, it's very difficult. So what we use are the grid lines on the graph to kind of summarize what's going on with the direction of the arrow. And you'll see how that relates to matrices. So we could have different vectors going in different directions. So what we're going to do is look at a specific arrow, like in this one, and have a look at how we'd represent that using vector notation. So we have an arrow, it's starting here, and this is where it stops. All right, sometimes in vector, the arrow is in the middle, and that arrow really just indicates the direction of the vector. Because if the arrow is pointing in the other direction, that would just mean the arrow is going downwards. We're going to try and describe this using vector notation, and we're going to look at this in terms of how it has moved across or up. So if we have our vector and it's say labeled A, B, we describe this direction as AB. All right, we describe that AB and we put an arrow to indicate the direction. Because moving from A to B is different from moving from B to A. The distance is the same, but the direction is different. So at all times when you do vector work, you should have that arrow indicating the direction that you're going. And just a simple thing, you put the two letters and the direction. But that is so important. Remember, it's a vector. So a vector, the direction is critical to understanding that vector. So yes, the distance is the same, but the directions mean different things. In fact, the difference with the two is one is a negative direction and one is a positive direction. So we'll talk a little bit about that when we talk about switching around vectors, the letters in a vector. So if we're going to describe this, what happened? We start to look at this and we're getting back into like matrices, and we're going to be using what we call a column matrix to describe the vectors. You can use anything you want to use for your matrix, for your brackets. It could be curved, nice, smooth, kind of like just normal brackets or squared brackets or curly brackets. It really doesn't matter in terms of how it is understood. It's up to you. I just went for this one because it was easier for me to use on the diagram here. So the first thing we do, we always go across first. To describe the movement of the vector, we always go across in the direction of the vector, of the arrow. So if we're here, we're starting from A to B, we must go across because that's the direction of the arrow. The arrow is going in this general direction, but we move across, and we're talking really about that distance, okay? And that distance at the moment, if we check them just in units, 1, 2, 3, 4. So that's really 4. Yep. Not necessarily parallel to the x-axis, but not, because this vector is just freely into space. There's no axis, there's no x-axis, there's no y-axis. We're just looking at the arrow from A to B, and then starting from A, but we must describe A to B in terms of its across movement or its up or down movement. If it moves in this direction, meaning in that direction, that's in the positive direction, we just say it's 4. So this is just 4. So that's 4. And we always put the across movement at the top. So we do across first, and then we look at how do we get from this point to get to here. We'll need to move 3 upwards, which also is a positive movement. So we count 3 and we write our vector like this. So this is how vector notation works. So if we can go back through that, we're looking at the movement from A to B. We know the general direction. It's going in this way, really. So we start from A, we move across in that way, always go across, and then we count that. That gives us 4, and then we go upwards. How do we get from this part all the way to the top, all the way to B? We need to move 3. And this is how we describe a vector in terms of its movement, moving it from an arrow into vector notation. Any questions at all so far? All right, good question. So you're looking at my next slide. Don't worry, we're coming to that one. So remember we talked about, if you're just going across, moving towards the right, yeah, what we call the positive direction, that's always going to be positive. If we go up it means it's positive. Now, the converse to that is that if we seem to be going backwards or moving towards the left, that's going to be negative. Or if we are moving downwards, it's going to be negative as well. Let's have a look at another situation here. So let's have a look at this arrow. So this vector here is drawn on the graph paper, and we're going to describe it using vector notation. So we know that it's PQ, so we need to write PQ. So that's going, see, now it's going what? -4, because we're going 4 backwards. Because we're at P, we're trying to get to Q. The movement from P to Q has to go in a backwards direction, or leftwards. So moving leftwards, that gives you that negative. So it's 4, but we know that it's negative. And that's different from A moving this way first. That's a positive 4. So we have 2 examples of 4. One where we're moving from P to Q. And to do that, moving, let's say, along the corridors and then up or down the stairs, we have to go along the corridors first. So we go across 4, going towards the left. And then we need to go up, upwards. And that's only 1. But that's a positive one because that's going up. Remember that if it's going up, we know that it ends with P, up ends with P, right? So it's positive. And if it's going down, down ends with N, makes it negative. So these are simple things you can use to help you remember stuff. When you're doing gradients also, that will be useful. So in this case, we can describe this as -4, 1. So as long as when we look at them, you'll see different examples as we go through, and you can try and preempt what I might be thinking on this. But the main thing is that we start off at the point where the first letter is given. Let's say we're trying to find PQ, and we go from P to Q by moving along the corridors first, and then up or down the stairs. All right, and if we go to the right, we have to give it positive. If we go to the left, we have to make it negative. If we're going up, it's positive. If we're going down, it's negative. Also, because we're going across first all the time, like with exact, when we're doing coordinates, the first number in this matrix or this bracket is going to be your X movement, and the second is going to be your Y movement. Now, one of the things I could ask you to do it, yes? Come again, repeat. I wouldn't go down because I'm traveling. Okay, good point. We're traveling from P to Q, right? Agreed? So if I leave from P here and I get to, let's say I'm leaving from Halfway Tree and I'm trying to go to my little country in Anata Bay, right? I need to go through Constant Spring. So what you're asking me now is, how do I leave from downtown or leave from Halfway Tree, go to Constant Spring, and then for some reason I'm in Anata Bay coming back to Constant Spring? That's not possible, right? So I am going through from P to Q. I have to go across, and then from here, the only way I can get to Q is what? Up. There's no, I can't just jump and start from Q coming down. I have to go from where I am to the next point. So that's the reason why I know that I must go up, because I'm trying to get up to this point. All right? That's how you describe the vector using the matrices. All right? That's just the reason for it. And as soon as you do a few, you'll kind of get the gist of it. Anyone want to tell me what this one would be? Vector AB. Vector AB. So tell me what would be in the brackets. Okay, and okay. Fantastic. So let's have a look and see. Somebody said no. Somebody says 6 and 3. All right, don't worry. No problem. All right, no problem. We'll check. It's not a big deal. The main thing that you're saying to me is the main thing, is that you know that the first number is going to be something 6 or 7. Because if you're far away, you might not be able to see properly. So I understand that. So let's have a look and see what it should be. So AB with the arrow, get our brackets together. And if we check, let's just check. That's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7. So the person who's saying 6 might just miscount it. All right, so that's 7. And then everyone's in agreement that going up will be 3. So this is fairly straightforward, right? And that's what vector notation would be. So when you're asked to describe a vector in this form, just remember that this is what you would do. Let's have a look at this one. Who wants to have a go at this one? Let me know. Okay, tell me who is me. Tell me who is. Tell me. Okay, go on, Britannia. Tell me what you think the answer will be. Somebody say. Some people say 4. I say Britannia. Where's Britannia? Britannia said me, sir, and then I don't hear anything more. 1. Okay, let's just have a look and see now. So we're moving from. All right, so let's see what's happening. Don't worry about it now. Let me see if I can walk you through it. So we're going from P to Q, the direction of the arrow. So if we're going from P to Q, we have to go in this direction, right? Is that a positive or a negative direction? That's a positive 4. That's not negative. Who said this from this direction is rightwards? We're moving to the right, so that's always positive, all right? So we're going all the way across here. So that's going to be 4. And then to get to Q, we have to go 1 downwards. And that's going to be 1, but it's going to be negative 1 because that 1 downwards, it's 1, but when we put it together, it will be negative 1 because we have moved down. Yes, question. In what way? Tell me. Yeah, yeah, you could do that, but you still have to put the across first. If you put P down, that's just -1. And if you go across, that's still 4. Yeah, you can. It doesn't matter. The order in which you do it is, I only tell you the order because I want to make sure you write the correct number first. But if you do P down 1 and then for as long as you put the X movement first, you're okay. Yeah. And it's just for simplicity why I just say go across first and then down. Because if you go across, you get the number, you write it down. When you go down or up, you get the next number, you write it down. It avoids you making a mistake, that's all. But if you look at it and say 1 and you know where to put them, it's okay. So I think everyone would be in agreement that this would be the way we represent this one. All right? Okay. So the next thing that we need, so that's how we would write these vectors. And it's important that you know how to do this. We're going to come back to that a little bit later, but it's important that you know how to do this. The second thing we need to learn is how to find the length of a vector. So I'm going to put this vector on. Anyone want to, well, this one we have done already. So we know that AB already was 7, 3, right? We've done this one already. Now, one of the things that we may be asked to do is find what we call the magnitude of the vector, okay? Which is meaning find the length of the vector or find the size of the vector. So you might find, it might say, find the length of the line AB. Because finding the length of the line AB is same as finding the length of the vector AB. Well, finding the magnitude of the vector, find the length, find the size, and when you start working those exam questions, you'll see these words interchangeably, but they all require you to do the same thing. How could we find the length of this line? Anyone sees an easy way to find the length of this line? Yeah, okay, I hear a voice there. Can someone tell me how we would use Pythagoras theorem? Why Pythagoras theorem? All right, one at a time. Somebody say? Okay, so we are, first of all, so in order to do this, we would realize that this side here, is it this side by itself? This side by itself, somebody I try to take over the class. Who is it? Adriel? Okay, thank you. All right, so we would realize that this side would represent, if we look, we can see that right angle triangle being formed, right? And I'm glad some of you see that connection, because that's really, really important that you can see that this really is a right angle triangle where AB happens to be the hypotenuse. So we have two sides. We know the length of the sides already. One is 7 and one is 3. So we can use Pythagoras to do this. Now, it's important that you know that this is Pythagoras. So you don't have to think of this as learning a new formula or something new. We're applying other areas of math into this. And the more you can see those connections, then the better you are. Rather than thinking there's a formula for finding the magnitude, it's literally Pythagoras in example. And you'll see that it's really going to be the numbers that are in this. So if you're given this without the graph, you can still know what numbers to use. Does that make sense? To find the length of the line. Yeah? So let's have a go. So how would we find the length of the vector? Now, this notation also means to find the magnitude of the vector. So if you're in an exam and you just see these two lines around the vector, like just AB, just like that, with those two lines, you can just know that it's also asking you to find the length of it. And using Pythagoras, we know. So yeah, what I was pointing out here, when you see this, you really don't need the arrow anymore, because when you're finding the length of something, does the direction matter? It doesn't really matter. But you won't lose marks if you have it. But like me, because I know that it doesn't matter, I tend to just don't have it. Yeah? And the exam question may not have it. But don't worry, the length of a line is not the same. Is it? Finding the length of a vector is the same as finding the length of the line. And that's why we can switch from vectors into Pythagoras to do this. So we know Pythagoras already. I'm assuming that anyone who has missed those lessons, you need to watch those videos. We don't need to go into like the detail of it. We know we're just going to add 7 squared plus 3 squared. And as we work through that, to get to the answer, it's fairly straightforward. Square root of 58. All right. If you're having problems with Pythagoras, you can go and read again about how to do it. The good thing is that once you've been given the numbers in the bracket like this, it's really just basic finding the length of the hypotenuse. You're always going to be finding the. What time? Who is this? Hello? Oh, it's not me. No, that wasn't me. Okay. So this is basic Pythagoras. If you don't know to use Pythagoras, then you can always watch one of the videos that I've shared already with this. Yeah, I knew it wasn't me. So yeah, this layout is a basic idea of how to find the magnitude. So I won't spend too much time on it, because I think when you start working through stuff with Mr. William, you'll see a lot of questions that ask some of these type of questions. But the main thing is, just remember, the reason why we can just use these numbers is because really you're forming a triangle, all right? But if you don't see the triangle, you can just carry on knowing you just square, square, add them together. But as someone pointed out, this is still Pythagoras theorem. So it's not a new formula, it's just Pythagoras to find the length of the line, all right? And when you did coordinate geometry, you'd have seen the same thing. It's Pythagoras again. Pythagoras really comes up in math in a number of different ways. So if you can see the connections and transfer that information, it's easy for you. So that's Pythagoras on that one. So no problem, I understand. The thing about this is, if the question asks you just to find the length of the line and it didn't give you a degree of accuracy, then this is okay. If it says to you, write your answer to 2 decimal places, then you will know that you need to just work out the square root. Does that make sense? Yeah. And if they say 3 significant figures or whatever it is, that's when you know what to do next. If it says something like, give the length of the line in exact form, then this is what they're looking for. Yeah? So that's something to bear in mind. Okay, so now we're moving on into vectors. We're looking at adding vectors. So I'll walk you through that. Let's say we have a vector here, AB, and by now you should know how to write AB here. I'm going to write AB as -5 and 2. It's a little bit off, but I'll count it as 2. Yeah, because we went 5 backwards, yeah, or 5 to the left, and then 2 upwards. Yeah, so AB is that. If you have another vector, and this one is PQ, and let's say PQ is going to be quite straightforward. Who knows the answer for PQ? 2, 3, yeah. So we need to remember to say the 2 first. 2, 3, yeah. So we have, it's 2, 3. Now, one of the things we could be asked to do is to add the vectors together, okay? So they might say, what is AB plus PQ? Or find the length of it, add the two vectors together. Adding vectors is simple like adding matrices. So let's have a look. PQ, AB and PQ, we just add the ones in the corresponding positions, just like matrices. So it's very straightforward. -5 plus 2 is going to give you -3, and 2 plus 3 is going to be 5. Make sense? That's why we did matrices first, because now you should be looking at this and going, oh yeah, that's an easy one. It's not the long ones that have 6 things in it. All right? So that's straightforward. Let's look at an example. We have some examples here. We have 3 different vectors. A is -1, 3. B is 2, 5. And C is 3, -2. Now, when you're doing vector work, the vector is normally written, especially when we don't have like AB, but just A equals, B equals, C equals. It's normally written in bold. But when you're writing in your books, you can't do bold. So we normally expect you to just put a little line above it to say that it's a vector, or underline it, actually. So that's just a basic thing. It doesn't really hurt anyway at all. It's just something. So, yeah. Now what I'm saying is, in vectors in books, it tends to be bold. But when you're writing, you cannot write in bold. You don't have the text. You can't write in your book with bold. So you can just underline it to show that it's a vector. Yeah. Yeah, that's what it is. But it doesn't matter really. If you didn't underline it, you're not going to lose marks for that. Just to make it clear. All right, so we have some questions here. We have A plus B, 3A plus 2B, A minus B, C minus B plus A. And there we have this. Anybody remember what this means? Find the length. Yeah, it's the same symbol for determinant, but it's not, in this case, it's not determinant. It's just finding them. Here's another term, modulus as well. So there are a number of terms that they'll throw into it, and it's just for you to know that they're all the same thing. And then if you know the correct operation, then it doesn't matter. And you'll maybe do a question and you say, what does this mean? And someone tell you and say, okay, it's the same as. So always bear that in mind, that there are a number of ways. And modulus is one that I didn't even remember, but thanks. That's another way. And modulus is also another function in math as well. So just need to be mindful of that. So let's work through some of these. I'm not going to spend too much time on it. A plus B just means put A and B together, work that out. So we get 1 and 8. So very straightforward. I'm not going to make it seem like, you can have a look at this again if you think I'm going too fast with this, but it's matrices, so I think you should be able to see where we're going with this. Similar to matrices, if you're asked to find 3A plus 2B, we just need to, okay, I think I did this one first. So this is A minus, this is C. Sorry, I might have just put them in the wrong order. So C minus B plus A. So I'm actually ended up doing 4 first. Doesn't matter. So let's go through that. So 3 minus 2 plus 1. Does that make sense? So we'll just work through that. 3 minus 2 plus 1, that should give you, I think, 2. And then minus 2 minus 5 plus 8 should give you a positive 1. Yeah? I'm doing C minus B plus A because of the order that it seems like I've set up there. I kind of made a mistake, I think, in the order in which I do that. All right? So that's this one, number 4. Okay? All right. So let's carry on. Yeah, go on. Could you repeat that, please? Oh, yeah, hold on. I think I made a mistake, right? Oh dear, sorry. I put the wrong thing in. I think what he's saying is that I use 1/8 here. Yeah, you're right. I just realized I made an error. I just put the wrong thing. So yeah, I made a mistake. This should be here. 1 minus 1, 3. Right? Is that what you're saying, right? All right, let me just edit that quickly. You're right, man. You'll see. This should be A. Yeah, I'm just fixing it. Don't worry. I'm fixing it. It's not a problem. This should be minus 1. Yeah? Is that what you're saying, right? And it's correct. The correct vector should be C minus B plus A. And I use this by mistake. Okay? So I'll correct that. So 3 minus 2 plus minus 1 will just be 0. Is that correct? And the last one would be minus 2 minus 5 plus 3, which makes it, I think, minus 4. Sorry about that. When I'm doing these, I sometimes type the wrong thing in. Let's fix that, sorry. Good spot. Okay, I hope I haven't made any more errors because I'm copying and pasting those in, and it's quite possible I could make an error there. All right, so I just bring that back up. A good spot. So yeah, that should be minus, and that should be okay now, yeah? Yeah, yes, exactly. So yeah, I think I just copied the wrong one and I actually did something wrong on the order here as well. I hope I haven't made any other errors as I went through very quickly. All right, so if we're going to be doing number 2 now, okay? So number 2, we have 3A, got A right this time, and 2B, got B right this time, right? Happy, I'm very happy. So substitute, it's the same like with matrices. So we just need to multiply it out. 3 times minus 1 is minus 3. 3 times 3 is 9. What's wrong with me? Why did I make so many? I'm maybe not as focused as I thought I was. Let me just fix that because I don't want you to copy the wrong thing or have the wrong thing. So that should be 9. I don't even know how I have 4 there. That is just me not thinking. And then that should just be 19. All right? Sorry about that. I think I'll have a few of those because I was maybe trying to get through it today. I was a little bit busy. All right, so back to where we were. So that should just be minus 3, 9, and multiplying by 2, we should get 4, 10. So that's what we're evaluating here, okay? Okay, and then we just simplify after that. Minus 1. And that should just be 1 as well. I don't know why I'm rushing. I think I just made an error. Is that what you're saying? It should just be 1. Yeah, man. I just maybe just type it. I think it's positive. Yeah, I realize. The good thing is that you guys know what to do, and I've just made an error in the typing, so I'm just adjusting them very quickly as I press play. Then I realize that I've messed up the calculation there. All right, so get there quickly. Da, 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 da. Yeah. Well, 3 minus 2 is what? 1. 1 plus negative 1, 0. Minus 2 minus 5 is minus 7, plus 3, negative 4. Okay? And this one should be 119. What's that? Tell me. I just realized I'm gonna have to make an adjustment somewhere here. Tell me. No, I actually think I have missed out number 3. Can someone work out number 3 and tell me the answer in the meantime while I adjust this one? Okay. Everybody agree with that? Because I actually don't have it. Sorry. Yeah. So she said, so it's B minus A, right? Or A minus B. So negative 3 and 2. And negative 3 and 2, right? Okay. So that should be fairly straightforward. I don't know what happened on this slide. I think I just had a few numbers all over the place and it has messed up all of the other calculations. Okay. So negative 3, negative 2 for 3. No problem. For this one, last one, we're asked to find the length of 3a plus 2b. 3a plus 2b, we already know the answer, it's 119. So we can then use Pythagoras. And as I said before, you should really just be okay with using Pythagoras now to get to the answer. So the square root of 62. All right? Square root of 362. How am I doing for time, Mr. Fullerton? He's not here. Okay. So we're going to get into something called position vectors now. Someone asked me before about on a graph. Now, when we talk about position vectors, we're normally working on a graph with x-axis and y-axis, okay? Let's go down, I've lost something. Okay, I'm trying to find my laser. Okay, my internet is going a bit slow. Okay, so we're working on a graph. So notice here, we have an origin. So we have that O at the origin. And I have a point Q. Now, normally what will happen in exams, they'll maybe say, write down the position vector of the point Q. What's the coordinate of Q, by the way? Anyone knows this? What's the coordinate of Q? 2, 4, 6, 8, 8, 6. So 8, 6. So the okay, good. So when we talk about position vectors, so if you say write down the position vector of the point Q, reality, what they're asking you to find is the vector OQ. So when you see the position vector of the point Q, you can just go straight to the idea of finding the vector OQ, because that's what we mean by position vector. And the vector OQ is always going to be connected to the coordinate of Q, because it's just going to be 6, like normal. Okay, so the position vector of the point Q, if we know the coordinate of Q, we just know what the position vector is. We can just kind of flip that coordinate into a vertical formation, like a column matrix. And that's it. The position vector of the point Q is the vector OQ. Always O something. The position vector of the point R is OR. The position vector of the point P is OP. And that P normally is a coordinate point. Yes. Yes, 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 yes. All of this is going to be 1 centimeter is 1 unit. Because otherwise we'd have a problem with you guys trying to count in between. But good question. Yes, 1 centimeter is 1 unit. To be honest, even in vectors, even if we weren't calling it 1 centimeter, 1 unit, the end result would be still the same idea. Because as long as we're using the same scales, it really doesn't matter in that sense, because we're not doing accurate lengths. We're just doing length based on the system we're using. So, but good question on that point. So that's position vector of the point Q. Let's look at another one. Let's look at Q, another point P. What's a position vector of the point P? Anyone can tell me? Okay. So we're looking for OP. Remember, we're looking for OP, and OP is negative 5, 3. So the position vector of the point P is negative 5, 3 in that bracket form, in this format. So when you see a question that says, what is the position vector of some? That's it. That's how you write it. Okay? Because now the reason why it's called a position vector compared to the other ones were just on a graph. There was no way to know exactly where it was. It was what we call a free vector. So when the other ones we're looking at, they were just lines on the graph. In this case, the vector OP is a specific graph, specific line. There's only one line that is OP. And when we say the position, it doesn't use it as a reference. It's just a line on a space. While position vectors are related to the X and Y axis, and it uses an axis if it's position. So that's when we're speaking about a specific type of vector. That's why it's called a position vector, because it's really, the position is important. And that's why we go OP, because O is always the origin. And on every graph, there's always going to be an origin. So if I say to you, the point, for example, let's look at this example. The points P and Q has coordinates minus 5, 3 and 2, 7, respectively. Respectively just means that's the order, meaning P is the first one and Q is the second one. Okay? Write down the position vector of P and Q and then find the vector PQ. So let's have a look at this one. So P, if there's a P, we can put that down minus 5, 3. And OP, we know what that will be. So we already find the position vector of P, minus 5, 3. What about Q? Q is here. That's the vector Q. The position vector will be quite straightforward, which will be, let me just write that down, 2, 7. That's okay. We know what we're doing there, okay? Now we want to find the vector PQ, but we don't have any information for that. Now there are a number of ways we could do this. One, we could say PQ, just like any other vector work, count across, all right, and then up. Agreed? To go from P to Q, we could go across and then up. But that could get a little messy. So what I'm going to do is use some matrix work and some vector work in order for you to see how we could do this. So one way we could think about this is to get from P to Q, we need to go first from P to O, and then from O to Q, because we know these lines already. We have information about this. We have information about OP, we have information about OQ. So we could say, to get from P to Q, we can go from P to the origin, which is always on a graph, and then from O to Q. The reason why this is important for you to understand is that not every vector work you get will be on graphs. Some of them is just going to be with the information, and you're going to have to do the work. So we're going to learn how to do this work without the graph, but we're going to check using our graph to see that what we did was okay. So if we want to find PQ, what I'm saying that to find PQ, we can go from P to O, and then from O to Q, and that will still get us in the same place, all right? So for example, if a ship wanted to go from P to Q, if it goes from P to O and then from O to Q, it would still get there. It would get to the same place. It may not travel the same distance, but it will still be in the same place, all right? So when we're working now, one thing to remember, this is knowledge I'm giving now, if we change this, if we don't have information on PO, what we have information on is OP. Now, all we have to do in vectors, we can switch things around, the letters around, but we need to remember to change the sign. That's all. So if we say, I know that OP is this, if I want PO, I just need to switch them around and change the sign. Change the letters around, change the sign. And that's how vectors work in that sense. If you just turn the other direction, it's just the minus vector of that direction, okay? And of that particular vector. And you'll see how that works once we get through a few problems. So I'm rewriting PO as minus OP, all right? OQ we already have, so we don't need to change anything. But OP we do not have. We just know that OP, this is the relationship between the two. So from PO, we just need to change the sign and we'll now be able to apply that. How does that work? Let's see. We know OP, so I'm putting a minus sign in front of it, okay? And we know OQ, which we don't need to do anything with because we know this already. Minus 5 will give you positive 5, agreed? Positive 5 plus 2 should give you 7. And then minus 3 plus 7 should give you 4. Okay? So the main thing here is to understand this part. Why isn't it? Minus 5 makes positive 5. Right? And 5 plus 2 is 7. Minus 3, because this will multiply both. Remember, that's how it works, right? So minus 3 plus 7 is 4. Yep. Because we need to get from P to Q. So the only way we can do it is from P to O and then O to Q. But the information we have is not PO. What we have is OP. The relationship between the two, if I want OP, I can switch the letters around, but I must change the sign. So if I want PO, it's the same as writing minus OP. That's all. So it's something you'll have to get used to with vectors because we're going to have to do a lot of that. The switching them around and change the sign. Yep. Okay. So as I said, so we are here, PO plus OQ. This part, this is the vector triangle, and I'll do a number of examples with this. What am I doing for time? These are taking longer than I thought they would. All right, so what happened to my arrow? Okay, here we come back. Sorry. What's that mean? Okay, yes. So the key thing to learn in this one is that we do not have the information for PO, but the relationship between PO and OP is one you need to learn. And in this case, PO is equal to minus OP. A simple way of remembering it is if you switch the letters in any vector like that, you just change the sign and then you get that relationship happening. The reason why we need to do it, we do not have anything for PO, but we know OP. That allows us to make this substitution here. Minus OP. Remember that OP is minus 5, 3. So I put a negative sign in front of it. Yeah. Yeah, the thing is I didn't put any, what it called on it. That's why. But I'm going to show that the answer is the same. Yeah? So from P to Q, if we were to write the vector from P to Q, would have gone here all the way across. That would be 7 and then 4 up. So, but remember, as I said, not every question will have a graph. So that's why you have to learn to do the calculations here. Don't worry, I'll do a few other examples and you'll start to see that trick. That trick is a very common thing that you have to do all the time. So it's not something that you're going to have to think, when do I do it? Quite likely in almost any vector question, you're going to have to make this switch around. So it's just something to remember to get yourself out of the problem of doing this. All right, let's look at another one. Don't worry about it. So we have A and B. Okay, so a very simple thing you might need to ask is understanding parallel vectors. So a vector A, a vector B. This is an example of two vectors which are parallel. I'm going to show you that they are. Two vectors are parallel if one is a multiple of the other, meaning if you multiply one of them by a number and you'll get the other one, then they are parallel. All right? So we have A and B. So A is minus 1, 3. If we think about B, we can see that B is really 3 times minus 1, 3. How do we know? In a sense, you're kind of like factorizing. But I don't want to use that term here because it could create its own problems. Just notice that 3 times minus 1 would have given us minus 3, and 3 times 3 would have given us 9. So because this is happening, if you notice, this is 3 times A. And so B is equal to 3A, or 3 times A. It's just something to get used to, because the question might ask you to show that they are parallel. Or you may finish a question and say, what is the relationship between the two vectors? And you could see that one is a multiple of the other. And you'll see this when you start doing other questions. It will just come out in a natural way. It will just make sense. For now, it's just something to remember that one is a multiple of the other. And if we were in like a setup where I could draw lots of stuff, I'd show you some examples as well. So since B is equal to 3A, then A and B are parallel to each other. This is how we know that they are parallel, because the vectors are, one is a multiple of the other. Also, B is 3 times as long as A. Okay, that's just a factual piece. So B is equal to 3A, both in length as well as in terms of the vector relationship, where it says that they are parallel to each other. All right, that's just information, and we'll use that later on in other questions. Let's see if I can get a few questions done, sir, and then I'll try and stop in 10 minutes. All right. Yeah. I'm going to share all of this in a, but take a screenshot if you want. Okay, no problem. But that's just information, okay? So we're asked find the vector BH. And as you can see, it's a little bit, because I've been trying to do this very quickly and I haven't gotten to clean up the slides properly. We're trying to find BH. Now, the thing about BH is that we have BQ, which is minus 2,5, and we have HQ, which is minus 1,4. The question asks us to find the vector BH, meaning from B to H. To get from BH, we need to think about what might be happening. If we know BQ and HQ, it means that there's another letter that's involved, right? Q. But you can't see it. So I'm just going to give you a representation of what may be happening. We have B, we have Q, and we have somewhere where there's H. We're trying to get from B to H. To get from B to H, we have to go B to Q, because that's the information we have, and then from Q to H. How do I know this? That's the information we have. We have H and Q and B and Q. So it's just something to bear in mind. This is a piece where vector B moves into the abstract space. We're trying to find BH. We look at the information and there's a Q involved, but that's not given here in the question we're trying to find the answer to. But that means Q is in the relationship. So all I'm saying is B is somewhere, Q is somewhere, H is somewhere. This is a diagram. It's not an accurate representation of it. And you don't have to have an accurate representation of it. You just need to understand what's happening here. So B to H, we don't know B to H. So we cannot go that route. We're trying to find the answer to that. What we do know, we could maybe go from B to Q and then from Q to H. And I spoke to you about that trick. That will help you nicely here. So we know that BH is equal to BQ plus QH. We know that because that's the outcome. BH is going B to Q and then from Q to H to get us to that point. All right. These things happen a lot of times. For example, if there's a ship trying to move from, say, B to A, a ship could be anywhere, and there's in the middle of this, there's an iceberg. They need to get to the point H, so they have to go to a point Q and then go from that point to the point H to end up back where they really want to go. But this route isn't possible. So we're going to try and work out what is BH. All right. BQ we know. That's given exactly as we want it. We're going to have to check. We're going to get to it. We have QH, but what do we have here? HQ. So what do we need to do? And change it around. That's all. So negative and change them around. Now we have what we want, we can substitute. So we know that BQ is that, and HQ will be minus of HQ. Sorry, QH is minus HQ. So we have HQ, and there's my minus side. All right. I can work through. I can get rid of the minus sign. That will make it positive 1 and minus 4. Agreed? And then we just add them together. And someone did say minus 1 and 1. Okay? And this kind of work that we're doing is called the vector triangle. You'll get used to it once we do a few questions. You'll see. I have maybe 2 more questions. And then I'm sure when Mr. William and you're working out, you'll have a lot of examples. Yep. Yeah. Yeah. Yeah, man. See it here now? 1 and minus 4. See? Yeah. So it changes around. Yes, it does. It changes the sign. I mean, if you're confident, you don't have to do all the steps that I'm doing here. You could just know that those are going to change around and done. But the main thing, I have to show you the steps, and then for you to develop the confidence to do things and leave some of the numerical steps. All right. Have another one. Find the vector BH this time. Yep. Oh, sorry. William, I may need maybe 5 more minutes, yeah? I know I started a bit late as well. But I'm coming to the end now. Okay? All right, so one of the things that you may see with vectors as well is that the vector is given in algebraic form. So the ones that we're doing so far are all with matrices, and the methodology is fairly straightforward. Adding the matrix here and there should be okay. Sometimes the vector work begins to go into an algebraic form. They'll just describe the vector as A and HQ is just B. But these are vectors. How do we know it's a vector? Because we have that arrow. Okay? So it says vector BQ is A, vector HQ is B. And you may think, oh, it's getting algebra is going to be a bit tricky. But let's say you're given that we're trying to find BH, same idea. B to H is going to be B to Q and Q to H. So I'm just creating the same question, but with letters now, because we're going to do some letters type question. Same thing happens, BQ plus QH. We know what happens here. The sign has to change. And to flip them around, because the information we have is HQ, not QH. So we need to get HQ in relation to QH, QH in relation to HQ. We know that BQ is A, and we know that HQ is minus B. And to simplify, it's just A minus B. So when it gets to algebra, in fact, it kind of gets a little bit easier when you get algebraic vectors, because we're just kind of just playing with the algebra here. And the procedures are the same. Okay? And that's done. If you want to ask me, it's done. A minus B is BH. Yep. Because we are given, the reason is, look, the information we know that BH is BQ plus QH. We know that, right? Because to get from B to H, we need to go from B to Q and then from Q to H. Agreed? Done. All right. It's the same as if you want to catch a bus from Buff Bay to somewhere else, to Montego Bay. There's no direct bus, but you can get one from Buff Bay to Port Murray and then from Port Murray to Montego Bay. So you can't get a direct bus. So there's another way to get there. You go to another point and change. So I'm just saying that's the route in which we're going to use. But the problem with the route is we know BQ because the information is given exactly like that. QH, though, is not the same. You see that? That says HQ. So that's why we know which one to switch. Yeah. All right. It's a little thing to get into our head, but we'll be fine, I guarantee. All right, so let's have a look at another one. Find the vector CA. We have some information, a little bit more algebra involved. A plus B. So AB is given as a vector A plus B. BC is given as a vector 2B plus C. We're asked to find CA. Okay? You maybe will know what the answer is, but we have 3 vectors in space. One of them is C, one is B, one is A. 3 different points, sorry. So CB, we want to find CA, so we have to go from C to B and B to A. All right? Now, when you're doing this vector work, it's important to notice that the middle terms will be the same, and the end ones are just a starting point. So one thing you can do, and I think Mr. William will show you this better than here, if you're trying to find CA, you can actually write C, then A, and then figure out what the middle one is going to be. Where is it going to be the transfer? And that's going to be the same all the time when you do that vector triangle. So it's something to look at to check if your work is on track. All right? Carry on. We know what's going to happen. Here's the issue now. Someone asked about how you know which one to change. What I'm saying is, once you get used to it, you should see the pattern where I'm trying to find CA. The vector equation will have C and A at the end. See that? CA. See at the beginning in the first one, A at the end in the second one, and the middle terms, they are the same all the time. If you look at all the others, you'll see that. And there's a reason for it, but it's also something you could quickly look at and say, oh yeah, I've written the right thing down. Now, someone asked me just now, how do you know which one to change? Now look, we have CB, the information that we get is BC. We have BA, but the information we get is AB. So in this question, both of them need to change. Yeah? 2 of them have to change because we don't have it in the way we want it. Make sense? Tell me what you don't get. Because I need to do, at the end of the day, you have to have a vector equation. So to get from C to A, I need to go from C to B, and then from B to A. All I'm writing down is my procedure here. Now, if you are able to see the answers, you could just quickly write these down, but not everybody will. So I can't write down a step that doesn't connect. C to A is the same as C to B and B to A. All I've done is written down an equation that gets me from C to A. Now, I have to know that I don't know CB, but I know BC. So I know that CB is minus BC. And I know that BA is minus AB. That's the stuff that I said is going to be a regular part of your work. So you're going to have to get the equation right and then do those steps after. Let's have a see what we have here. Let me go through and then we'll see if we're on the right track. So we have minus AB. What am I doing here? I think I've written the wrong, but it should be okay. The order might be in the wrong order. And minus 2B plus C. So the order is not correct. I should have put them in the order. The math won't be incorrect, but the order. This one is BC and this one is AB, yeah? I just got strapped for time today and I couldn't get to quality assured, like checking again. But this should be okay anyway. When we expand the bracket, we'll end up with minus A minus B. I have to check this, sorry. I have to fix it. This is just what happens if you do stuff on a rush. And I had to do that on a rush today because I was just so busy. Sorry about that. So that should be minus A. And that should be minus A. Yeah? Yeah, that should be okay now. Okay. So I didn't get a chance to just check it over. Don't worry, kind of rush, guys. Okay, so when we expand, we'll end up with minus A minus B. When we expand this, we'll get minus 2B minus C. So if we're going to simplify this, we'll end up with minus A minus 3B minus C. Okay? Okay. Yeah. And this is, it will look algebraic and all that, but the work is really the same. The main part of the vector is just learning about the vector equation. because minus b minus 2b is minus 3b. Yeah. And we can't do anything more because you can't simplify anything more. Yep. You mean here? I wouldn't use the term inverse, but if it allows you to understand what's happening, because it's not really an inverse of it. It's just a different direction. So it's just saying that going from C to A, if you go from A to C, that's the negative direction of AC. That's really what it is. It's not really an inverse in terms of what we mean when we use inverse. It's just something to remember when you're working with vectors, that the direction is important, but the opposite direction is always just interpreted as negative. So if C to A is one thing, A to C is a negative of C to A. That's how it works. Okay. Last example. ABCD is a parallelogram. M is the midpoint of AD. M is the midpoint of CD. So we can see that. Midpoint meaning it's halfway. N is halfway between all of this. So technically DN is the same as NC in both vector and length. So let's look at what you're asked to find. AC, BD, and AM. What's AC? Anybody can tell me what AC is? What's AC? No, I mean in vector form. I wouldn't be hypotenuse because we don't know if this is a right angle, right? You agree? Yeah, because we're going from A to B, right? And then B to C. So the answer really is very straightforward, 2A plus 4B. All right, notice the arrows, very important, because A to B tells you is that direction, and the arrow is saying 2A. This one is saying 4B in the same direction that we need to go from A to C. We need to go A to B, and then B to C. And that's just 2A plus 4B. What about BD? Now, BD, let's have a check. Let's check. So we want BD, so we're going from B to A, and then A to D. All right? So we should have minus 2A and plus 4B. And I made a mistake here. It should be 4B. That's just because I'm rushing. I just literally, I wasn't 100% with it. But we're on the right. The correct thing is 4B. Sorry. So that should be minus 2A plus 4B. Or 4B minus 2A, as someone was saying. All right? And the reason why we know it's 4B because the arrow is going in the correct direction. All right? So that should be minus 2A going that way, and we're going along the 4B direction. So that's okay. The last one, AM. Go from A to M. Note that AM is really half of B. I don't even know what I wrote here. That's wrong. So William, this is the one I did just before I come online. You know? So this is half AD. All right? That should be okay. Yeah. So yeah, that should be okay. So it is half AD. No, half of AD. Well, not necessarily. We don't need to do any minus 4B because the direction of AM and AD is the same as the direction of the BC vector, right? Because it's a parallelogram, we know that the opposite sides are equal in length and parallel. So it means that AD is the same as BC. Agreed? And so it's just half of AD. It's half of AD. And AD, we know the answer already. So it's just 2B. All right? All right, so there's a lot there, but when you start doing the practice questions, you'll be able to go back through a lot of the stuff that I shared with you. Sorry about the little errors I made with the signs and the numbers because I was just rushing through, but I think you should be able to get the basic idea of what's happening. These vector equations are really important that you practice seeing those vector equations, because on this diagram, you may even have questions to say, what is BM? Yeah, and that's going to be like going BA plus AM, stuff like that. What's MN? MD plus DN, those kind of things. I mean, you could also do MA plus AB plus BC plus CN, but that's another practice on that. All right, Mr. William, I think I've come to the end. Yeah. I think I'd give you half an hour. Really?
All I'm doing is working questions. So we're going to just put all the knowledge that we were given earlier together in trying to solve questions and seeing how we can
I'm just checking
bring
if
this information out. Okay?
Checking
now,
if the YouTube link is working. Sorry.
It was. Man. The points A, B, and C have coordinates A being -2, 8, B being 4, 2, and C being 0, 9. M is the midpoint of the line segment AB.
Okay, it's working. Yeah.
It says express each of the following in the form XY. In other words, they're saying express it in vector form. That's all they're asking us. Now, OB is, we've got B being 4, 2. So OB, when expressed in vector form, would be 4, 2. Because remember, the X ordinate is written first or at the top of that column vector, followed by the Y ordinate, which is at the lower section. Okay? Then we are asked to find AB. Now, this is where AB is not given inside our information there. But we know that we're going to travel from A to O, and then we're going to travel from O to B as a vector. Now, when we travel that route, we have already established that the vector OA is -2, 8. But we're not going OA. We're going, it's a negative of OA plus OB. What's OA? OA is -2, 8. So it's a negative of -2, 8 plus OB, which is 4, 2.
4, 2.
Yes? So the negative of -2 is +2 plus 4, which is 6. And the negative of 8 is -8 plus 2, which is -6. Okay?
Sir, could you please go down to library?
Okay. So here, let's do this. It's like this. Good. So we are doing the negative of OA. OA is, so it's going to be the negative of -2, 8 plus OB, which is 4, 2. Okay? So the negative of negative 2, negative 2 is going to be positive 2. Positive 2 plus 4, yes? And we'll have negative 8 plus 2. And we'll end up with 6 negative 6. Okay? Next part of the question says we should find OM. M is a midpoint of AB. Yes? So if M is the midpoint of AB, look at how nicely this works out now. M is a midpoint of AB. What would be OM?
3, sir. 3, negative 3, sir.
3 negative 3?
Negative 6. 3 negative 3.
How did you just pop it up? I'll write 3 negative 3. But you've got to tell me how it comes
Half
up.
of AB.
It's halfway, yes?
Half of AB.
Half of AB.
It's half of AB, which is 3 negative 3. Why did I have negative 3 written like that? Yes? So 3 negative 3. Okay? Good. It says use a vector method. Show that AC and OB are parallel. What did Dr. Barker mention about parallel vectors? What do they
There are multiple, sir.
Multiples.
multiples? So there's a scalar multiplication of each other. Okay? So let's look at it then. We want to find AC. Did we work out what AC is? Or do we look at OB? Yes, so I think we know what OB is. OB is 4, 2.
4, 2.
So let's write that down. 4, 2. Yes? Let's find what AC is. AC is AO plus OC. Yes? That's something we need to always remember. Yes? So we are moving from A to O. A to O is a negative of OA. Yes? Plus
Yes.
OC. What is OA? OA is negative 8, 2. Yes? So that's going to give us 2 negative 8. Because we worked that out already right here. Yes? Agree?
Yes, sir.
Okay. And we're going to have OC. And OC is 0, 9. Yes?
0, 9.
0, 9. So when I work this out, I end up having 2, 1. Agree? 2 plus 0 is 2.
Sure.
Negative 8 plus 9 is 1. Yes? Now, looking at what we have here, we can say that OB is twice AC. Isn't that so?
Yes, sir.
And so that tells us that they are parallel. That's one way we could look at it. We could also look at the... No, I'm not going to go there, but we could use a line segment and we could use gradient. We can look at gradient, but we're not going to look at that. Yes? Not at this moment. Okay. Let's
Sir,
yes.
isn't it supposed to be negative 2 or 2, 8? 2 negative 8?
Where?
Right there, instead of the 2 below the OA and the negative OA.
Yes, here, yes?
Yeah, shouldn't it be a negative sign on the outside?
Yes, okay. So because that's perfect. Remember here, I skipped a line. I skipped a line because we did it here. So we put a negative on the outside and a negative 2 on the inside and the 8. which that negative on there changes it to 2 and -8. So that's why I have the 2 and -8. No? All right, let me show you. Sorry, don't want to have any confusion with you. So let's look at this. This should be negative of -28 plus 0, 9. But remember now, a negative of -2 gives me +2, right? And a -8 would give me the -8 there. Okay? It's just that I skipped a step out because this portion was done in the previous part of the question. Okay? Right. Let me give you a couple of minutes to have a look at this one. I'm going to give you 4 minutes to have a look at this one. Yes? Before I start working. 4 minutes. And then I will start having a look at it. This is one of the most important part of the work, because now that we have learned the concepts, you get an opportunity to attempt the questions for yourselves, yes, before I work them. So you will solidify, consolidate what we have just learned. Yeah? Ryan, you made mention of the, is it Ryan? Ryan, you made mention of collinear. Collinearity also exists. We can use that to say it may be collinear. Doesn't have to be collinear. If it is twice, it will work. It's a multiple, but not necessarily that they are collinear. They can be parallel, but not necessarily collinear. I hope that there is a question there that will look at collinearity. So. Yes, it is. I think it was for the first question. Yes, for the first question, you're correct. That OB is a scale, has a scalar multiple of AC. Yes. "30 seconds approximately, and then I will start working the question. Now, this part of the question asks us to find the magnitude. Yes, it says calculate the value of OR. They're asking you to calculate the magnitude, they're asking you to calculate the length, yes, of vector OR. So we know what we have there. R is negative 3, 4. Yes? So what we have, if we want to think about it, you will get a right angle triangle. Definitely looking in this direction from the origin, if this is what we are looking at. Yes? Having that being the taller, something looking like this. Yes? I just want you to know that's the idea. Yes? So in order to do that, then we would have to say OR vector, the magnitude of OR would be equal to the square root of negative 3 squared plus 4 squared. So that would be 9 plus 16. So that's 9 plus 16. I think it's 25. So it's a root of 25, which is 5 units. Okay? Just write, always write units for in your response. Okay? Now, it says express in forms of x and y the vector rs and st. Rs, it's going to say it. Rs is what? Ro plus os, straight. Yes? That's what we're going to do immediately. We're traveling from R to the origin and from origin to S. Now, RS
Sir,
is a
question about the previous equation. How did you get rid of the negative
I haven't got
on
that.
the negative 3 sign?
Oh, when I square negative 3,
Negative
becomes-
times negative.
yeah, it becomes a positive.
Oh, okay. Yeah.
Okay? So this becomes a negative of OR, vector OR, plus OS. The negative of OR, because this is R, and then we've got S's beside it, okay? So we've got OR is the negative of that would be the negative of negative 3, 4 plus 1, 1. Okay? And my answer for that would be what?
4, negative 3.
4, negative 3. Okay? I'm going to do ST over here. Yes? And ST would be SO plus OT. And why I go O? Because it says that it was in reference to relative to the origin O. That's why we're using O. There are times that a diagram would not necessarily have O in it, but so we need to know what letter to use. Okay? We're going to that reference point. Yes? So please remember that. So for us to find ST, ST is a negative of OS plus OT. OS is 1, 1. But we want to find the negative of 1, 1 plus OT. OT is 5, negative 2. So it's going to be what? 4.
Negative.
4, negative 3. Yeah.
So they say, using this information here it says, using the results of combining vector B2, justify that RS is parallel to TS, and that RST is a straight line. Now, who raised? Somebody raised a point about collinearity earlier. Ryan. Yes? So that's what they're saying, that RST is on a straight line. And we're going to justify that. That RS, there it is, RS is parallel to ST. They are parallel because they are running in the same direction. They are going in the same direction. That's what makes them parallel. Yes? But look at what I'm going to do now to prove that point, because it comes from here, yes? We now need to find, it says RST. But what I want you to notice is that RS and ST, I want you to see that. RS and ST. Good? So if I look at it and they ask us to say RST, which exists down here, that they are on a straight line. To prove that, I'm going to have to say that RS plus ST, that would be equal to RT. That's the thinking that I'm going to bring out. So because I've already found out what RS is and I know what ST is, I need to find what RT is. Let's figure out what RT is. RT is RS plus ST. So we've got the vectors there, but I can put the RT here at the front, since that's what we are used to, only because we are used to that. Okay? Now, did we work out what RS was?
Yes, sir.
RS is what?
Yes, sir.
4, -3.
4,
4, -3. Did we work out what ST is?
Yes, sir. Yes, sir.
4, -3. So what is RT?
8,
8,
8 negative? 8 -6.
yeah.
So I want you to pay attention to what's happening now. Good? I'm going to try and use some colors to help us. That's a line segment. Good? Assuming that I draw this yellow line perfectly on top there, yes? I draw it with an edge on it so that you can see where it is. Not because I want to say it doesn't exist on it. It's a line on top of it. So if I draw a line there, no, hold on, a line segment there, and then I draw another line segment on top of it like that. Are those two line segments parallel? They're unsure.
That long line on the shorter one?
No. The two, let me erase this. Those two that I put there, the green and the purple, are they parallel?
No?
Why no?
Yes, they are.
And let me ask you a question. Let's assume that my two line segments are my two pens. Can you see my pens? My hand.
Yes, sir.
Yes, sir.
Yes, sir.
If we assume that they are parallel like this, if they are like this, are they parallel? Still.
Yes, sir.
So
Hmm.
if they sit on top of each other, they are parallel. And if they are beside each other, they are parallel. Yes?
Yes.
So that's the same thing that happens. So let's look at the principle again. If I've got that, and I then draw another line on top of it, but I didn't go all the way further, are those two lines parallel?
Yes.
Yes,
Yes, sir.
Yes, sir.
Yes, they would be parallel. And that's the same principle that we have here. Yes? We've got, if looking like this, R, and we've got T, and we've got S in the middle. But S is halfway where those two sides are the same measurement. Yes?
Sir,
Yes?
to prove that RS plus RT is parallel, ST is parallel, sir. You wouldn't have to use RO plus OT to justify it, sir.
Okay, so you want to do, you can do that. RO plus OT.
Oh, sir, and one more question, sir. Wouldn't it also be a multiple, sir, because they multiply it by 1? So RS would be a multiple of ST.
Yes, because here, what you're talking about here, the scalar multiplication is 1. The scalar multiple there is 1. But look at what they're asking. Yes? So these are parallel. We established that. Yes? Also, here, these 3 lines are parallel. You see that? So this
Yes, sir.
is parallel, that's parallel, and that's parallel. Let's prove from what you want to say, because that could be a way of doing that. So we could find RT by saying RO plus OT, and that would give us RT. And I need to be using my thing over here. So what's RO? RO is a negative of OR.
Negative OR.
Yes? And then we've got OT. What is a
5.
negative OR? It's a negative of -3, 4. And OT,
Yes, sir.
OT
5
is what?
negative
5 -2. Yes? So what do we have there at the top there? We've got a +3 and a -4 plus a 5 and a -2, which gives us what? 8 negatives. Same difference. Okay? So we could use thing. But the important thing is not just this. It is stating the collinearity. And the collinearity is saying to us that we want to say that the line segment RS, I'm going to write this in colored, different color. So we want to say that RS plus ST is equal to RT. Yes, we want to say that RS is a multiple or scalar multiplication of RS. RS is a, and RT are multiple of each other. So I can say that this is 2RS is equal to RT. Yes, because twice the RS, any one of them RS there, twice that is equal to RT. So these are the 2 things that you can look at to see that. All right? Looking at the segments. And that's segments. That's collinearity. So that it's really saying that they are in line. For them to be in a straight line, they've got to be sitting on parallel lines. They've got to be parallel, and they must be going in the same direction. Yes? And in one straight line. And that's what we're going to use to do that. All right, so here we've got a 2-mark question, a little more than 2 marks, but I can't show you more than 2 at a time. So I'm going to do like that and give you 2 minutes, and let us see if we can work these. 3 minutes, and let's see if we can work these 3 questions, 3-mark questions. Should be easy. I hope you can see the screen. We only have 3 minutes. Oh, We have 3 minutes for the end of lesson 2. So we'll be able to finish off. Do apologize for those who have not gotten their bulletin this week. We will ensure that you get it next week. A matter of fact, I think Dr. Barker would be able to send out last week's one bulletin to those who didn't get it as yet. Are you still there, Dr. Barker? Are you able to send the bulletin to those who didn't get their bulletin this week? You're not hearing me. All right, so let's look at this one because our timer is running out and I don't want us to stay here. What's this?
OR, sir?
6/2.
Yeah, 6/2.
6/2?
Yeah.
When we talk about 6/2, 6/2 is a what?
A fraction.
A fraction. 6/2 is a fraction. Are we talking about fractions here? No.
No.
So what should we have? 6/2.
6/2.
Okay, thank you. And then it says OS. OS.
-4/3.
-4/3.
-4/3. Okay, so that's 2 easy ones. And then they ask us for SR. SR. Good?
10 -1.
So S is
SO plus O.
SO plus OR. But
Yeah.
SO is a negative of OS plus OR. That's a negative of OS. We have
-4.
let's say 4 -3. All right.
With the negative side.
Let me not jump the gun because I'm gonna get knocked out. Yeah. What's OR? OR is 6/2, yes? So here I've got now what? 4 -3 plus 6/2. And my solution would be 10 -1.
Yeah.
Good. And you can actually test your answers to see if that's the case. We go 2, 4, 6, 8, 10, and 1 down. Okay? And that would be our solution. There's another part. Oh, there are 2 parts. Didn't see that. It says find the magnitude of OS. The magnitude of OS, they're asking you to find the length of OS. So OS would be the square root of -4 squared plus 3 squared, which is equal to the square root of 16 plus 9, which is the root of 25, which is 5 units. Okay? So one more question. So you know you're not going to require a lot to do. It says, given that OT is that, prove that they are parallelogram. How would you prove that they are parallelogram? How can you prove that? No?
Oh, sir, well, sir, there would be like scalar multiples are they'd be going on the same line, sir. So all you have to do is add ST plus TR. You have to add SO plus OT plus TO plus OR. And if ST is the same as TR or a scalar quantity of each of them, you know that it's a parallelogram.
Yes. The scalar multiplication would be 1 though, in all the cases, yes? Okay, so if the scalar multiplication is 1, then it would be the case. So what you need to find is, in order to prove this, as Kingsley raised, we need to find what SO is and RT. So let's find that. SO, we need to find what RT is. Yes? And then we're going to find, we know what OR is, so we need to find ST. And what did I say? OR? OR. That's what we need to find. SO we know. SO was given to us as it's what? 4, -3. SO is a negative of OS, which is negative of -4, 3, which is 4, -3. Good? RT, let's work what RT is. RT is equal to RO plus OT. Yes, which is a negative of OR plus OT. So negative OR, it's a negative. OR was what? Tells us what OR is. OR is 6,2, right?
26.
6,2. Negative of 6,2, yes? And OT they say is 2,5. Yes? So that would work out to be -6 plus 2 is -4. Yes? And -2 plus 5 is 3. Good? So we have,
Excuse me, sir. Excuse me.
go ahead. Did I do something?
On the graph, right? How you establish T?
I didn't even establish T. I just gave a sketch. There's no need to establish T, but T was given as 2,5 here. OT is 2,5 here.
Oh. Yeah, thank you, sir.
All right. So I could actually say 2, which is 1, 2, and then 1, 2, 3, 4, 5. So T is
Sir,
actually there.
you
Yes.
can go back down a little bit, please.
Sure. Yeah. But did I do something wrong here?
Sure, yes, sir. For the SO, it should be OS, so it should be -4, 3.
What's OS? OS is
Yes, sir. So down at the bottom, it should be -4, 3 because SO is 4, -3. So OS would be -4, 3. So it'd be equal to RT, which is -4, 3.
Okay, so you're saying to me that
Yeah.
there should be no,
Sir.
hold on. SO, hold on. Let me see what I'm doing here. SO. SO is,
Sir.
yes, hold on.
That's what?
SO is 4, 3. 4, -3. SO is 4, -3. SO is 4, -3. This is what it should be.
Sir, it asks us to find like OSTR, sir.
Hold on, we're gonna look at it. We're gonna look at it. Hold on, because we're looking at parallelogram. Yes. Don't worry. I don't think we are off. We're not necessarily off. Look at what we have: SO and RT. So we've got SO. Okay, you see, because T is here, and I'm saying SO and RT. I should have done RT and OS if I'm putting it in the same direction there. But that's what I did here. Yes? So that's why. So I can just do OS. I don't need to find SO. I can just do OS. So OS is equal to -4, 3. That's fine. Okay? That would make it the way we are thinking about it. And then we want, let me make sure that this doesn't go catch me out now. So I want to find ST, and OR. Yes, ST and OR should be the thing. Yes. So OR was given as 6.2, right? OR is 6.2. OR is 6.2. And ST would be SO plus OT. What's SO? SO is a negative of OS plus OT. Yes? Negative of OS is a negative of -4, 3 plus OT, which is 2.5. Yes? So here I've got now what? 6. So that's going to be +4, -3, and 2.5. So I would end up with 6.2. So here they are parallel. So I can say that, the point I'm going to have to make, let me make a statement. I've got to be able to say that ST is parallel to OR. And I have to use the vectors because they are vectors. They are parallel because they are going in the same direction. Yes? And if they are going in the same direction, yes, and they've got a scalar multiplication of 1, so the scalar multiplication of 1 between both of them means that they have the same length. Yes? So they've got the same length there. And I'm going to also say that OS is parallel to RT. So OS is parallel to RT. And so that's what we have. And so because they are parallel, and not only that, and they are equal in length, for both of them, equal in length. Because remember now, with a parallelogram, they've got to be equal, opposite sides have to be equal. And that's what's happening here with this pair of parallel lines. So this one is parallel to this, and it's equal in length. And this one is parallel to that, and it's equal in length. And that's what the diagram would show. That this line is parallel to that line, and it's equal in length. The magnitude is the same. And here as well, we can find the magnitude as well. Okay?
So can you go back this, please?
Yes, sir.
Say that again?
Could you go back down to the statement, please?
The last statement. Okay, good. Because remember, these two would have the same magnitude. So I could also state, I need to also state that ST, this could I say, ST, the magnitude of ST is equal to the magnitude of OR. And the magnitude of OS is equal to the magnitude of RT. Okay, guys, thank you very much. See you next week, same time. Just know every week we'll be here. If you don't get a message, it means that we're here. If you get a message to say we're not here, then, but I can guarantee you that Dr. Barker and I are committed, and the rest of the team are committed to be here for until you have sat your exam. Yes? Yes, we could say, we don't need to say direction. We don't need to give the direction in this case. Okay? Thank you, guys.
Thanks.
And yeah, you're welcome. And tune in for next week. I think that Dr. Barker will try and send out for those who miss their bulletin. I'm gonna try and encourage him to send them out for the bulletin for today, for last week's one. Can we have that, Dr. Barker?
I'll try my best.
All right. Okay.
Thank you very much. I appreciate it and have a good day, everyone. Bye.
Thank you. Bye-bye. Have a great day.
Enjoy your Sunday dinner, sir.
Thank you, sir. Bye.
You guys can enjoy your dinner. I had mine about 6 hours ago.
Bye and thanks, sir.
Okay, Kingslayer. Take care.
Thank you, sir. Bye.
Okay, bye-bye.
Thanks.
I have no worries at all. You're all welcome. Bye-bye. General.
Yeah, I'm not running into a conference right now. You know that, right?
Oh, you have a conference on, don't you?
I'm in the next 5 minutes.